Next generation.
Okay, so this is the Okapi 1 circuit board kit, and this is the Okapi 1 wiring kit, and I'm going to show you how to connect the wiring kit to the circuit board kit. Okay, inside the wiring kit we have the two temperature sensors, one for the inlet and one for the outlet. We have various receptacles which you'll add later onto the wires. We have an inlet wire which is already pre-made. The receptacles are already on there for you. And the outlet wire, which is 7-core, we already have the contacts crimped on there for you. But the other end we need to cut this to length and then strip off the insulation and then solder it into the circuit board. And here is the circuit board. I'll take it out of the bag and show you where the wires connect. Okay, you'll notice on this board there are lots of holes. The board's actually designed for both Okapi 1 and Okapi 2, but in this configuration with this specific microcontroller it will only operate the Okapi 1. So we have the two fan connections here. We have the ground and the positive, that's plus 12 volts. And see on here we have the inlet wires, inlet 1. We have the outlet wires that run to the outlet thermistor. And we have the PWM control for the fan. So I'm basically going to strip that insulation from those wires and solder in the relevant wires into the correct holes here. Okay, this wire here is for both the inlet and the outlet in the fan. It is 7-core 22 AWG. Okay, I'm going to strip about 2 to 3 inches of insulation off here. There we go. Just when you strip that outer insulation, just check for nicks on the inner wires. If you have a nick in there, it could cause a problem later. So I just want to make sure there are no issues there. I'm just going to strip about half a centimetre or so of insulation off each of these 22 AWG wires here. So we have a green and a white pair, that's going to go to the outlet thermistor. We have a brown and blue pair, that's going to go to the inlet thermistor. The orange is for the fan, for the PWM. Red is plus 12 volts for the fan, and the black is the ground for the fan. There we go, so they're all nicely stripped. I'm going to solder those into the circuit board. Okay, I'm going to start by pulling the ground wire. So you see in here we have the fan 1 voltage outlet here. So we want to solder in the ground, the black wire, into the hole on the left, and the red, the plus 12 volts, into the hole on the right. So I'm just going to feed through the black wire first of all. You can use whatever method you prefer to clamp the wires in place. Sometimes they just fall in place when you lay the thing on the table, and I find that quite easy. Other times it's a bit easier to use the helping hands. The solder we use is 0.2 inch gauge, and it's lead free. It's a very, very fine gauge. It's very easy to work with, even though it is lead free. There we go. So that's the ground wire in place. Now at this moment I'm actually just going to do the PWM, which is over on the other side of the board. just makes it a bit easier to get the rest of the wires. So this orange wire goes into the F1 PWM. Okay, so we've done the ground wire and the PWM wire, and now it's just a case of putting the other wires through the holes and soldering them in place. It's just a little easier to do it with the ground in and the PWM in first. Just allows the wires to sit in the board without you having to hold them in there with helping hands or any other method. Okay, so again, the inlet wires are the brown and the blue. Inlet is brown and blue. Just feed those in. So brown and blue go into inlet 1. It doesn't matter which way around. They just connect through to a thermistor, so there is no sensitivity with polarity there. And the outlet wires are white and green. So in the OT1 holes, you have two OT1 holes. You place your white and green. And get them nice and tight in there with the insulation tightish against the board before you go ahead and solder those in place. I'm actually going to use the helping hands here just to assist holding those wires in there. There we go. Let's make sure you got heat on both the pad and the wire at the same time. The most important thing there when soldering in the connections. Again, this is lead-free solder. I know a lot of people don't really like working with it, but with this really fine gauge solder, and no problems at all. And that's it. It's all 7 connections placed into the board. I'm just going to trim those wires now. Okay, I've got the leads nicely trimmed now, and just double check the wires are in place. So we have fan 1, so ground, 12 volts, inlet, we want brown and blue pair. Outlet 1, we want the green and white pair. And fan 1, or F1P as it's marked on the board, that should be the orange wire. Okay, I'm actually going to test it before I do anything else. Okay, this is the power supply I'm going to demonstrate with the unit. It is a triad. It works pretty well with the Okapi 1. It'll give you a full amp of power, which is way more than the board and the fan running at full speed actually require. And 12 volts is the output. Cool things about this power supply, it's pretty light. It's reasonably inexpensive. This is the actual power supply we supply with the full Okapi units for the United States. It comes with an over voltage protection, but one of the really cool things about this power supply is that it has short circuit protection. Bring up a voltage meter here so you can see. Okay, and here's the barrel, so I'm just going to clip the ground, the return, onto the outside of the barrel and probe into the center. There we go, and we have 12.12 volts, pretty stable. So let's have a look. Just going to use my tweezers and short it out. There you go, it shorts right out. Voltage drops, no sparks, no fire or explosions. Take away the short and back up to 12 volts. So that's a really nice feature of this power supply. Very safe to use. Okay. So I'm going to plug the power supply. So again, it's 12 volts, center positive, 2.1 2mm jack into the receptacle. You'll see straight away the light blinks one time. That's just a boot feature to indicate that the light is working. And then it's going to flash a number of times, 3, 4, 5, and that's it. 5 flashes, so you would look that up against the list of error codes. Basically what it's telling us is that the thymistors are both open. We haven't actually attached them, so just it's aware that there are no thymistors attached, so it's not going to work. It's not going to send power to the fan. It's not actually going to do anything apart from signal that error code. Use the error code, identify what the issue is, fix the issue, and the board will immediately come back to life and start to operate. Okay, so I'm now going to mount the Okapi inside the box so you can see how that all goes together. It's a pretty straightforward process. So this is the box kit that we supply, and obviously it's optional, but you can, if you want one of these, you can pick one up on our website. Comes with the bolts for the lid, and also supply a couple of spacers and 2 bolts to connect the Okapi board into the box. So what we want to do, power supply in first, and then push the contacts through, just gently push those through. There we go. Connect up the power supply, and that's pretty much it. Now then, you can tighten this. With the Okapi 1 it is actually a little bit slack. It's perfect for the Okapi 2, but what you can do is just put a little bit of foam or just a bit of wire trimming inside the cable gland just to give it a bit more sturdiness. Now then, I'm going to screw the board in place. So there are mounting lugs on the back of the board and 2 holes in the PCB. So the mounting lugs are in the box. These are short M3 screws or bolts. It just screws nice and tightly in place. Now that holds everything pretty well. What we do for the fully manufactured board is use these spacers. And I just use the bent needle nose pliers to put the spacers in place. And just slot those underneath, and you can just put a drop of glue in there just to secure that in place if you want. Pop the other spacer in. Again, just slide that underneath, match up the holes, and glue that in place there. And then for the lid, just drop the lid in place. And then just screw those down nice and tight in place. And there we go. Now the next thing to do is connect the receptacles to the contact pins, and then you can go ahead and wire it into your solar collector. Okay, so now that the Okapi is mounted in the box, I'm going to connect up the receptacles that you would receive with the wiring kit. If you're doing the wiring yourself, you do get thymistors with the Okapi circuit board, whether you buy an Okapi 1 or an Okapi 2. Obviously 2 thymistors come with the Okapi 1 and 4 thymistors with the Okapi 2. So with the Okapi 1 wiring kit, we also provide 2 thymistors which are already mounted for you in receptacles, and these are the female receptacles I'm now going to mount on the contact pins. So basically this is where you are going to plug your fan in, and the colour code here is really straightforward. It's just red, black, orange. So 12 volts, ground, PWM in that order. And start with, you see the triangle at the top, that's where we're going to put in the red, or black in the middle, and orange on the bottom. So just feed in those contacts. Just firmly push them all the way in. Push them in with the tip of your nail, or use needle nose pliers, which perhaps a needle nose plier which just doesn't have any grooves, just it's nice and soft, so it doesn't pinch the wires, just to make sure they're all nice and tight. Okay, and then we're going to look at the pairings again. So remember, it's green and white as one pair. Doesn't matter which way around you put these in. You see the triangles at the top, but it doesn't actually matter which way you go there, because they just connect to a thermistor, and it doesn't care about polarity running through it. So again, just push those contacts in, they should lock in place. And then the brown and blue pairing. And it doesn't matter about polarity, so it doesn't matter which wire is in which hole. Push those in place, and there we go. Now, I'm going to put, as the green and white is for the outlet sensor, this sits directly behind the fan, and we can just put the thermistor directly in there. Just clips in place. So if anything ever happens to this, it's just a case of unplug it and get a new one from our website. Once you receive that, just plug it in, put it back behind the fan, and it should be all set. And with the wiring kit, you'll also receive this extension wire, which is approximately 9 feet long. If you do a custom order, you can actually get that to the length you require. So this will allow you to put the thermistor in the inlet. So this works as a convection sensor as well as a room temperature sensor. So just squeeze that all in place. There we go, just clip that in place, and it should be good to go, and put that inside of your inlet at the top there near the ceiling, and that will detect convection and then also room temperature when the fans are running. And the other end we just plug into the brown blue pairing here. It should just clip right in place. There we go, nice and easy. And the remaining receptacle will be plugged into a fan. And here's the fan kit that you can also purchase from our website. This fan we've tested on numerous solar collectors, and it's pretty much our favourite for a few reasons. I wouldn't say it's the cheapest fan in the world, but it's designed to last for 70,000 hours at 40 degrees Celsius. So you should, I would imagine, see possibly 5 to 10 years life out of it at least. It's 12 volts. It has quite a high static pressure rating, which means if there is airflow impedance in the system, it should do a good job of overcoming that, as long as it's not too significant. Maximum draw here you'll see is 1.5 amps, but to be honest, when it's running, it'll draw about 800. The entire system will draw about 850 milliamps, and you never see that draw because the fan never actually revs up to full speed, as it's controlled by the Okapi system. So if you buy this fan from us, it'll come already equipped with the contacts and the receptacle there. So of course this will just mount directly in to the Okapi wire, so just make sure your reds and your blacks and the yellow and the orange all match up. The yellow is the PWM control. It also has a blue wire, which I have cut it short and just taped it in there. If you want to look at the tachometer, you can do that through connecting to that blue wire, so I have left that as an option. This fan also comes with a finger guard. It is a very powerful fan. Yeah, it's only 12 volts and it doesn't look all that big, but it is a very powerful fan. It'll push out up to 110 CFM, and there are the bolts and the nuts for you to attach the finger guard. Please do that. Okay, and then we're ready to test the unit. Okay, so I'm just going to plug the power supply in, and the first thing to do to test the unit is just take a look at the outlet sensor and pinch the thermistor, and almost immediately the fan should switch on very slowly. Why is it doing that? Well, it's detecting a temperature rise between the inlet thermistor, which is over here, and the outlet. Just a tiny little bit of temperature from my fingers is enough to switch the fan on. In other words, it's detecting that there is a rise in the solar collector, and right now it's trying to pull that heat through the solar collector. The next test you can do, once the fan winds down, you can cool it down more quickly by obviously exposing it to the cooler air from the fan. There you go, and it switches off. Next thing you can do is actually use a heat gun on this thermistor. So this inlet temperature sensor, the Okapi is basically monitoring it, looking for a level of convected temperature from the solar collector. So it's looking for about 85 to 90 degrees Fahrenheit, and then once it finds that, it'll switch on. It'll switch on for a time duration, and what it's trying to do is pull all of the heated air through the collector, and then heat this outlet thermistor. And once the fan is running, this is the inlet temperature sensor is then monitoring room temperature, and the outlet temperature sensor is monitoring the heat rise between the room temperature and the outlet. And so long as there is sufficient heat rise, remember it's also monitoring the ambient temperature inside the box, as long as there is a sufficient rise, the fan will run, and the fan will run proportional to the temperature rise, and it will also have a rate of change which is determined by the actual weather that's being tracked by the Okapi unit. So if you have a cloudy day, the unit will slow down and speed up. It'll slow down more quickly, and it'll speed up more slowly compared to a fully sunny day, where it'll be monitoring and realizing that there are many warming temperature trends as the heat builds up during the course of the day. So the unit will speed up more quickly. It's obviously a lot more complicated than that, but this system has been tested on many different solar collectors over the course of about two full years, and I think I've got the code pretty much nailed down to be able to monitor and track weather so sufficiently that it'll try its best to keep the fan running at all times. Of course, with a solar collector, you need the fan running, you keep the air moving, and that's going to give you heating. And that's pretty much it. Check out the other videos for more information. Thanks for watching.
Next